something that is a huge basis for things that we do in many chapters, including chapter 3. Specifically factoring. Factoring is a skill that gets used in a lot of different places in math because of the fact that what factoring does is it breaks things into the smallest things getting multiplied together to create something larger. And knowing what things multiply together to make something else can have a lot of different uses. It has uses in working with polynomials and fractions. It has uses in trying to solve things that have that situation going on. Now, before we get to factoring, though, we're going to remind ourselves a little bit of some quick things with simplify, some things that I've noticed have been a bit of an issue. Starting off real basic, 4x parentheses x minus 3. What do I do when I see something like this and I'm asked to simplify? Distribute, multiply it through. What is 4x times x? 4x squared. What is 4x times 3? In this case, negative 12x. Do be sure that you get your positives and your negatives together. Okay? What if it looks like this instead? Now what do I do? We're distributing again. When you're distributing and it's multiple parentheses, everything in the first set of parentheses gets multiplied by everything in the second set of parentheses. For some reason, this is causing some issues with some people. So, I FOIL it out. First, outside, inside, last. Some of you might remember from algebra doing kind of a box. If you do the box, you can do the box. You just will never see me do the box. 2x times 3x. 6x squared. 2x times negative 8. Negative 16x. Do I have to multiply the 2x by anything else? No. So I move on to the 1. And I distribute it. 1 times 3x. 3x. 1 times negative 8. Negative 8. Now, after you distribute, you should always combine like terms if possible. It's not possible on ones like the previous one, hence I didn't talk about it. Which ones are the like terms? Just the regular x's, not the x squared. This. Be careful when you're combining like terms. Keep the signs with them. Negative 16, positive 3. Combines to negative 13. Does it become x squared? No, it's just regular x. Okay, got one more similar to this before we move on to actually doing the factoring. We had problems that looked like this pop up on our last test. But there were some issues with it. If I want to multiply that out, where do I start? Distribute the 5 into one of the parentheses is one option. I'll be honest, I find that to be the harder option. But if you want to do that, we could do that. The other option is distribute the parentheses into each other. I find that to be easier because then when I'm doing more multiplication, I'm working with smaller numbers and then multiplying by 5 afterwards. I don't care which you do, but you do need to make sure that you're distributing more than once. I prefer this, x times 2x. 2x squared. X times 3 plus 3x. Negative 6 times 2x. Negative 12x. Negative 6 times 3. Negative 18. And I combine my like terms. Way too many people on the test, which had similar problems to this, then just stopped right there. What did I not do that I still need to do? Multiply by the 5, specifically distributing it. This is technically in parentheses with the 5 in front of it. This is technically in parentheses with the 5 in front of it. Far too many people only multiply the 5 by the 2x squared and then stopped. Distribute it all the way in. 10x squared minus 45x minus 90. Please do make sure to distribute all of that through. Now in theory, this stuff we've done so far this semester. Now let's talk about factoring. Factoring is the exact opposite of distribution. It's undoing that multiplying through. Factoring comes in a lot of different forms. When you are factoring, there is always one form of factoring you should start with. It's called GCF, greatest common factor. It means divide the biggest thing out of everything that is possible. What is the biggest thing that divides out of 4x squared and 8x? 4x. They both divide by 4, and you can pull off x to its smallest power. Now that goes in front of the parentheses. You don't just divide it off and let it disappear. It goes in front of the parentheses to indicate that at some point it got multiplied through. And you divide the individual pieces. What is 4x squared divided by 4x? X or 1x, whichever you prefer. What is negative 8x divided by 4x? Negative 2. Remember, when you are dividing variables, let's say I've got an x to the 7th over an x squared. What do I do with the exponents?
Subtract.
Subtract. I get x to the 5th. So when I'm factoring something out, when I'm factoring an x out of an x squared, I'm subtracting the exponents. The invisible exponent's 1. 2 minus 1 is why I have an x to the 1st left. Before I write down B. After you've factored out the GCF, you generally want to check to see if things factor further. If there is no exponents left on the stuff in the parentheses, then it is impossible to factor it further. If there's exponents left, then there may or may not be a way to factor it further. There was no exponents left on my variables, or it was a x to the 1st if you prefer, so I couldn't factor it further. Tell me how you really feel. but you did it a lot louder. Greatest common factor has to come out of all of the items. Look at numbers first. My numbers are 5, 15, and 25. Biggest thing that divides out of all three of those is 5. Now look at the variables. I've got x's and I've got y's. You could take them to their smallest exponent that is on all of them. I've got x squared, I've got x cubed, I've got x squared. Smallest exponent that shows up on the x? So I can pull out an x to the power of 2. What about y's? Y to the first power. And I divide it off of each piece. What is 5x squared y divided by 5x squared y?
1.
I heard both 1 and 0. Which is it?
1.
1. When you divide something by itself, it's 1. When you factor out a GCF, the number of terms in the parentheses should be the exact same as the number of terms that there were before parentheses. So 1. This divided by this, I know it's going to be negative. 15 divided by the 5 is 3. X cubed divided by x squared is x. Y squared divided by y is y. And I move on to the next piece. 25 divided by 5 is a positive 5. X squared divided by x squared, 1, or cancels out because it technically would become 5 times 1, which is just 5. Y to the 4th divided by y, y to the 3rd. I see exponents left, which means now I need to check if it factors further.
It does not.
Do we have a question?
Where'd you get the 1 from?
This divided by itself, anything divided by itself is always 1.
Okay.
Okay. So, generally speaking, when we factor, most of the time we want things in what's considered a standard form for a polynomial, which means biggest exponents first, then decreasing in exponents as you go. I talk about that because this is kind of not in the right order, which I could rearrange, or I just at least have to recognize that written in the right order, I'd have a positive 5y cubed, I would have a negative 3xy, and I would have a positive 1. So the structure of this right here is some number in front of y cubed minus some number in front of xy plus some number. We do not have a structure for factoring anything like that. Only things that we will have structures for factoring are things where the exponents, as you go through, decrease by 1. Notice I got a y cubed? Means my next term should have y squared on it. It doesn't. There is an exception to that rule. We'll talk about that exception later. So, this one will not factor further. General rule of thumb. For now, if you see multiple variables, generally it's not going to factor. Further, that is. It could do a GCF. X cubed plus x squared plus 4x plus 3. Greatest common factor.
Not available.
1. A GCF of 1 we don't pull out of everything. It's pointless because then you're just saying, well, it's 1 times itself. Duh, everything is 1 times itself. So we don't need to do that when its GCF is 1. Instead, we need to deal with something else. I need to deal with some other form of factoring. What type of function or expression is this? What family does it fit within?
Standard.
Standard is not a family. It is standard form. Starts with a Q. Quadratic. Quadratic equations. in their standard form is ax squared plus bx plus c. That look familiar?
Yep.
If a is equal to 1, you can do what I call the shortcut in factoring. It's a shortcut because there is a longer way of factoring when a is not 1. We're going to talk about that factoring tomorrow. But when a is equal to 1, we could do what I call the shortcut, which says find two numbers that multiply to C and add to B. In problems like this one, where that A is 1, that x squared's got that 1 in front of it, you're looking for two numbers that multiply to 3, but when you add them, you get 4. Mitchell, you still awake over there? Okay. What are some things that multiply to 3?
3 and 1.
1 and 3. Anything else? No, those are the options. 1 times 3. Does 1 times, well, negative 1 and negative 3. But, do 1 and 3 add up to 4? Sweet. When you find those two numbers, you can go directly to the double parentheses, starting both parentheses with the variable and ending both parentheses with the numbers you found. Positive 3, positive 1. Ta-da, it's factored. This look familiar?
Yep.
Should. You did it in algebra, you did it again in geometry. That's a dying pen. Two x squared minus 10x plus 12. Every factoring should start with what?
GCF.
GCF here is
2.
2. Leaving me with?
X squared minus 5x plus 6.
And then I check, can I factor it further? The form that's left has an exponent to it, so maybe. Is it a quadratic trinomial? Is its biggest power 2?
Yes.
Does it have 3 pieces?
Yes.
That is quadratic trinomial. Quadratic trinomials? Shortcut is one of our options. Can I do the shortcut? Is the number in front of x squared 1?
Yes.
Yes. We ignore the GCF. Okay, so I look for two things that multiply to this, but when I add them, I get this. Multiplies to 6, adds to negative 5.
Negative 3, negative 2.
Negative 3, negative 2. If you do not know the numbers, now 6 is a pretty straightforward one, but if you do not know the numbers that multiply together to get this, literally just start listing them. 6 is 1 times what?
6.
2 times
30.
3. And then I would keep going until the number either gets as big or bigger on this side. My next one would be 3. That's the same size. Those are all my multiples. The next thing I look at is this. Has to be positive when I multiply, which means they're either both positive or both negative. If they add to a negative, that means they both have to be
Negative.
negative in this case, because positive plus positive is never going to be negative. In the end, yes, we get the two numbers that people were telling me. Negative 2, negative 3. Double parentheses. X minus 2 and x minus 3. Doesn't matter which one goes first. But put the GCF back on front. Got one more problem, and then we're going to be done with notes. 3x to the power of 3 minus 3x squared minus 468x. GCF? 3x. Divide out 3x and I'm left with
X squared minus X minus 156.
Is it 156?
Yeah,
No, alright.
I just did it to figure out if the greatest common factor was in fact 3.
It is. Can I do the shortcut? Is there a 1 in front of the x squared?
Yes.
Yeah.
I could do the shortcut. I'm going to look for two numbers that multiply to what? Negative 156. But when I add them, I get
Negative 1.
negative 1. If you do not know all the multiples of 156, again, just start saying 1 times what, 2 times what, 3 times what. 1 times 156. I ignore the negative at first. If you don't know what 2 times whatever is 156, you got 156 and a calculator to divide it by 2. 2 times 78. 156 divided by 3. 3 times 52. If I have to get things that add to a negative 1, am I anywhere close?
No.
No. If you notice you're not close, you can skip over some numbers, but be careful because you might miss the number you need. I just go through. If it doesn't divide nicely, I skip it. Oops, I forgot to divide by 4, didn't I? 156 doesn't divide by 5. 6 times 26. 7 times nothing. 8 times nothing. 9 times nothing. 10 times nothing. 11 times nothing. 12 times 13. The next possibility I'd be 13 times something, which that's as big as this, or anytime this number gets bigger or the same as this number, you've listed all your multiples. How many of these numbers in the pair need to be negative to make this work?
1.
One of them. Should it be the bigger number or the smaller number if it's going to add to a negative? The bigger one. Are any of the pairs going to add to negative 1? 12 and negative 13. X plus 12, x minus 13. Do make sure you are using the right variable. I happen to use x in all of my problems here, but is it always going to be x? No. Is this my final answer? No. Put your greatest common factor back on front. Does factoring look familiar? Does it look doable is what I actually meant to ask, because I already asked about familiarity.
Yeah.
I hope so. You've done it quite a bit over the years. And it's not going away anytime soon.